Hey folks, this is Captain Jones here to talk to you just a little bit about the history of computing. Hopefully at this point you've watched these two videos from Crash Course Computer Science about early computing. There's just kind of one or two things I wanted to clarify a little bit that at least for me kind of help place some of these advances into context. So what I want to do is elaborate on the fact that when we talk about modern computers, like when we say in this course we're gonna build a computer, what we mean more specifically is that we're building a computing device that has three very important qualities. It's a digital, general purpose, electronic computing device. And as we sort of dive into each one of these terms, I hope you'll start to see how early computers that you saw in the video, were powerful computing devices, getting more powerful. But it wasn't until kind of we had all these three specific adjectives together that we had what we would consider to be sort of a modern computer. So let me start by actually saying that digital and electronic are not the same thing. It can be something that we sort of confuse. Even if you tell me something, I've got this digital device, my brain automatically is going to think of like some type of circuit, but they are distinct. Digital just comes from the root meaning discrete, so things operate in discrete chunks. The abacus, which I've got a picture of right here, is an example of a discrete computing device. It's discrete because beads can either be on one side of the abacus or the other. There's no in between. There's no way to represent like a 10.5 on an abacus. It just operates on integer values. It happens to be a mechanical device also. So the abacus is an example of a digital mechanical device. On the other hand, I might build an op-amp circuit like I have diagrammed right here, in which the output voltage is very specifically related to the input voltage by the natural logarithm. So this is an analog device. These two quantities, the input and output voltages, are related in an analog fashion. But of course, this is an electronic computing device as well. So that's an example of an electronic analog computing device. Okay. So computers were digital, they're electronic. Another example of a mechanical computing device was Charles Babbage's difference engine. That was a mechanical computing device. And when we talk about electromechanical, kind of a classic one there is the Harvard Mark I. This is the computer that, if you remember from the video, was using the relays to sort of open and close switches or open and close circuits. So that's an example of sort of an electromechanical computing device. When we say general purpose, we are referring to the fact that the computer could potentially be programmed to do just about anything. Many computers, many powerful computers, weren't quite general purpose. They were built to perform very specific functions. So Charles Babbage's difference engine computed a very specific kind of set of equations. The Colossus, which is a tremendously powerful computer, was used very specifically to kind of break the German Enigma, and so it was specific in its purpose in that it performed very very specific cryptographic kind of functions to be able to help to break that code. It wasn't until you kind of got all three together, digital, general purpose, electronic, we finally kind of got a what we consider to be a modern computer. And the video mentions how the ENIAC was the first computer to sort of put all those three together. In fact, there's a quote from a textbook I was reading in preparation for this class that literally says, "A modern computer history starts with the ENIAC." So that's the example. The video kind of builds up to as being the very first modern computer because it has all three of these qualities. Second thing I want to just mention briefly is that sometimes you hear about computing history in terms of generations, which has to do with the underlying technology, the electronic technology that powers a computer. So once we sort of move into this electronic realm, we've got a couple of different ways that we can use electronics to form computers that separate these generations. So sometimes electromechanical devices are considered generation 0. When we say the ENIAC starts modern computer history, the ENIAC was powered by vacuum tubes. So anything that sort of ran off of vacuum tubes is considered a first generation computer. When the transistor was invented and you could use discrete transistors to build computing devices, those devices kind of formed the second generation of computers. After that, scientists were able to fit transistors into integrated circuits. Those computers that used integrated circuits are considered third generation computers. And then lastly, as manufacturing technologies got better and better, you could pack not just a couple hundred or a few thousand transistors onto an integrated circuit, but we're at the point where we can fit millions and billions of transistors onto small integrated circuits. And so at some point that sort of switches into what's considered fourth generation computers, which by many estimates is where we are currently. That uses a technology called VLSI, very large scale integration. That refers to just the fact that when you're manufacturing these integrated circuits, we've got millions and billions of transistors that we are able to manufacture on each of these integrated circuits. So that kind of partitions the computing history. Okay, the videos. The last thing I'll mention is that the videos talk very briefly about a couple of kind of lesser known contributors to computer science, specifically Ada Lovelace and Grace Hopper. But there are a handful of others of sort of underrepresented groups, specifically women and people of color, who made very important contributions to computer science. And I just wanted to kind of highlight a little list that I was able to put together. I'd encourage you all to do a little research and learn something new about these individuals you may have never heard of before, whose contributions are really important. You can Google any of their names, or I was able to pull some names from this link down here in the additional resources. But would encourage you all just to discover something new about a person who contributed importantly to computer science. Okay, that's all I got, folks. I'll see you next time.